Hello friends, welcome to another video in the GATE preparation series. In today's video we'll talk about normal distribution. Please understand this video is not intended for those who wish to understand normal distribution. In this video I'm straight away going to tell you the most important formula that you need to remember before you appear in any competitive examination, and I'm going to consolidate all the things related to normal distribution for a better remembrance. So a normal distribution curve would look something like this, and this curve has a speciality that its mean is located right at the center. So the most likely probability of happening is right at the center. This mean is also your median, which is going to divide the area of this normal distribution curve into two equal parts, and this is also equivalent to mode. So that's very important property of normal distribution, and mode is, by the way, the point at which you get the maximum probability. So in other words, you could say mean and mode coincide in case of normal distribution. And another key point here is that the general representation of normal distribution equation is this, where you have k, which is the value for the maximum value of probability that some random variable can achieve, and then this formula e raised to the power minus x minus mu whole square upon 2 sigma square, where mu is mean and sigma is standard deviation and sigma square is variance. I've already discussed this point that you'll find the mean right at the center of this bell curve, the normal distribution curve or the Gaussian curve, and the mean will take up the maximum value also. And mode is, by the way, the maximum value of this probability distribution function, and median is the point where the area is divided into half. Now let's take a look at two different questions that could appear. You could get a question like this, where the function, the probability distribution function, is given like this: k e raised to the power minus x minus 2 whole square upon 8. Now in this question it is clearly seen that this 2 is mean, and the denominator here is equivalent to 2 sigma square, from where we can easily find the sigma. Comparing the general equation with this one, comparing this general equation of normal distribution with this one, we get that mu is 2, which is also equivalent to median and mode, and 2 sigma square is 8, sigma square is 4, which is variance, and sigma is 2, which is standard deviation. And this is the most important formula for normal distribution, that the area under the curve is given by k sigma under root 2 pi, and the area is always equivalent to 1 unity. The entire probability covered by this area will be 1. So from there you can also find the value of k, because now that you know sigma, you simply need to put it equivalent to 1. So you can also find k, which is the maximum probability of. Now in the second question, let's look at this, where the normal distribution is given something like this. So this portion is k, and you need to find out mean and standard deviation or variance, and it is given that the mean is located at 10 and the probability distribution of x less than 5 is 0.2. So how do you interpret such a question? We know that the mean is right at the center of this bell curve, which is given to be 10, and the probability of the random variable less than 5 is given to be 0.2, which is given in the question here. Then you know that this mean is also the median, this mean is also the mode, so it will divide the entire thing into half. Anything less than 10 will have a probability of 0.5, we know that, So if we were to find out the probability of this area from 5 to 10, which is, by the way, the first question, we know that the probability up to this point is half, and from this the probability of x less than 5 is given to be 0.2, so we subtract 0.2 from 5, and the answer here would be 0.3. And another important property here is, because the mean is symmetric about the distribution, so the distance of mean from 10, if it is giving us an area of 0.2, the distance of mean from at the same distance in the other direction, which is 15, will also give me the same area, which is 0.2. We know that anything above 15 will also have the probability of 0.2, anything less than 5 will have a probability of 0.2. So the probability of anything between 5 and 15 is going to be 1 minus 0.2 and this 0.2. Important point, the probability of anything greater than 10 is 0.5, probability of anything less than 10 is 0.5, because mean is symmetric about the distribution. This portion is 0.3, this portion is 0.2, this portion is 0.3, and this portion is 0.2. So whatever you need is going to be simple addition of the areas. So the probability of x lying between 5 and 10 is 0.3, probability of x lying between 10 and 15 is 0.3, probability of x lying between 5 and 15 is going to be 0.3 plus 0.3, which is 0.6, and probability of anything greater than 15 is 0.2 because of the symmetric nature of the normal distribution. This is how you need to approach these questions. You simply need to take care of this area formula. You simply need to remember the journal equation, and in journal equation where mean features and where standard deviation features is what you need to remember. And I hope this quick tutorial was of help. If you liked the video, give it a thumbs up. I'll come up with another video in another day. Take care. Bye bye.